All right, in this video, we're going over section 1-2 functions. So, to start our discussion on functions, we're going to talk about what is a set. Well, a set is simply a bunch of stuff. Now, I know that's kind of generic, but let's look at a set. Say we have a set over here that contains A, B, and C. And then say we have a set over here which contains the numbers 1, 2, and 3. Alright, so this is a set, and this is also a set. So a set is just a bunch of stuff. That's all it is. It can be numbers, it can be letters, it can be symbols, it can be stuff on a menu board, it can be whatever. Alright. Now, what do we do with sets? How do we use them? Well, normally with sets, we take one set and we join it to items of another set. So let's say we join the A and the 1, the B and the 3, and the C and the 2. Alright? Now, these arrows here, they actually have a name. That name is called mapping. We mapped one set to the other, and we use those arrows. So mapping is simply a group of arrows connecting one set to another. All right, a group of arrows connecting one set to another. Now, as you can see, we started with this set, and then we mapped over to this set. So since we started with this set, this is our from set, and then this one is our to set. All right, since we started here, we went from this set. This is also our domain, which will be represented by X. And since we went to this set, this is our outputs. That means this is our range, or our Y values. So this is our output and our input. All right, very important to remember that. Your from set is your input, your domain, or X, and your set you're going to is your output, your range, or your Y. All right, let's help. I'm going to do a little kind of a cute example you'll probably think is funny. Just to help you understand sets, this is called the Taco Bell theory. And for the record, no, I don't eat at Taco Bell. Alright, so say you're in your car. Most of y'all probably drive. Don't laugh at my pictures, you probably couldn't do any better. Alright, and you're driving to Taco Bell. You get in the drive-thru and you see the menu. You have 1 which has some stuff. A 2 which has some stuff, combo 3, combo 4, etc. I'm only going to go with 4. Alright, there's our menu board. Alright, so then you order something. Alright, well when you order, you're telling that order to the cashier. Alright, and then you drive up and then you pay for your order. So here's the cashier, and they have your meal. Kind of drawing the pictures ahead of time here. All right, so when you order, say you order a number 1, all right? Well, the number 1 on the menu board, when you tell it to the cashier, say that means you want a burrito. All right, so number 1 is mapped to burrito. All right, and then say you got a friend in the car and he wants just a taco. All right, so he orders a combo 4. So then now the cashier knows that you want a burrito and your friend wants taco. All right, well, is this a function? The answer is yes. This is a function because each item on this menu board is mapped to only one actual food item. So it is a function because given an input number, given an input number on the menu board, you know the output. All right, so there's no doubt in your mind that when you pull up and order a combo 1, you're going to get a burrito. When you order your friend a combo 4, he's going to get a taco. All right, so that is a function. Okay, and this represents your domain. And then the items on the menu board, the items that you actually get represent the range. So combo 1, you get a burrito. Combo 4, you get a taco. All right, you order, you know what you're getting. Domain, range. All right. Now, if they somehow messed this up and a combo 1 got your burrito and a taco, all right, say they had a glitch in their menu system and you ordered a number 1, you got a burrito and a taco. That's not a function because a combo 1, you got 2 different items. All right, 2 different outputs. All right, so to be a function, 1 input is mapped to exactly 1 output. All right, 1-to-1, 1-to-1 ratio. Let's put some actual math behind this. All right, we know that X is our domain. We know that Y is our range. All right, so let's look at an example. X, Y. We'll just make a simple X, Y chart. 0, 1, 2, 3, 7, 9, 11, 7. Is this a function? Well, if we look, the values in our domain are not repeated. Since the values in our domain are not repeated, the answer is yes, it is a function. Okay? Again, because the values in our domain are not repeated. Even though 0 will give you 7 and 3 gives you 7, it doesn't matter if the range is repeated. It only matters if the domain is repeated. And the domain is not repeated, so yes, it is a function. Now let's look at another example, a quick XY chart. 0, 1, 2, 2, and then 7, 9, 11, 7. Is this a function? Answer is no, because if you look right there, 2 gives you 2 different outputs. You can get 11 and you can get 7. So this is not a function. Why? Because x equals 2 cannot give you both 11 and 7. It can only give you one output. It doesn't matter if 2 inputs give you the same output, but you can't have the same input giving you 2 different outputs. That is a no-go. All right, that is a no-go. So how do we tell a function solely from its graph? All right, how do we tell a function solely from its graph? So let's draw in the graph of y equals x squared. I know you know what that looks like. This is our x-axis and this is our y-axis. Now, how do we tell if this is a function? Okay, this is all you have. Say you don't even have the equation. Say they just give you a graph and they're like, is this the graph of a function? Well, just because you can draw it on the graph doesn't necessarily make it a function. All right? Because remember, a function, for each input, you get only one output. So for each x value, you get only one y. Here's the easy way to tell that. It's something called the vertical line test. If you can draw a vertical line anywhere, doesn't matter where you put it, and you only hit the function once. So as you can see, regardless of where my line is, I only cross the graph one time. That means that yes, this is a function, because I can put my line here, it hits it once. Put my line here, hits it once. Here once, here once. So there you go. Now, let's look at a different graph real quick. What about this graph? Is this a function? Well, let's try the vertical line test. Let's draw my line right here. I only hit it one time. So, is that a function? Well, what about if I move my line over some and draw it, say, here? You notice I hit it twice, so the answer is no, not a function, because I hit it twice. Okay, that's really all there is to the vertical line test. If you can draw a vertical line, hit the function, and hit the graph more than one time, it's not a function. If there's nowhere you can draw the line and hit it more than once, then it is a function. All right? Pretty simple. Last topic to cover here is function notation and interval notation. Function notation. So instead of writing y, we use a naming convention. We call it f of x. The f is the name for your equation, and then the x, that is the main variable. All right? And it is usually x. But it can be anything, doesn't matter. So, function f of x equals x plus 3. As you can see, anything I put in there, any number you add 3 to, you're going to get a different number out. All right, so now, how do we evaluate this function? Well, it's something like f of 2. What is f of 2? Well, since our function is x plus 3, you just take the 2 and put it in for the x. That's simple. Okay? That's it for function notation. Now